Our next presenter is Hallie Fishman from the University of Florida.
Hi, everyone. My name is Hallie Fishman. I am a grad student at the University of Florida. And today I'm going to talk to you about how invasive hogs alter salt marsh functioning, ecosystem service provisioning, and resilience. So salt marshes in the Southeast US broadly and in parts of the GTM are dominated by the Cordgrass Spartina alterniflora. But living amongst these cordgrass are aggregations of ribbed mussels that I'll refer to as mussel mounds. And these ribbed mussels form a mutualism with the cordgrass, where the cordgrass provides a solid substrate for the mussels to adhere to and settle on. And in turn, the mussels excrete nitrogen-rich waste that increases the primary productivity of the cordgrass. And this nitrogen input is so important for the cordgrass that you can see the individual mussel mounds in this drone image on the left. So every small green dot you see in this image is a mussel mound where the primary productivity is increased from the nitrogen-rich waste. But this mutualism between mussels and cordgrass is under threat by invasive species. Oh, sorry. So in the Guana River salt marshes, we see significant damage by invasive hogs. And these hogs are problematic throughout Florida and the Southeast broadly, but within salt marshes, they trample and root around and they eat mussels, which you can see in this rightmost image of crushed mussel shells in a hog footprint. And so with this study, I worked to understand the impacts of hog trampling, rooting, and mussel predation on salt marsh function. The first question I wanted to look at was, where are the hogs and what are their impacts? And to do this, I ran transect surveys in the marshes along the Guana River. So on both the Western Marsh and the Eastern Marsh, which are outlined in this map on the right. And in each of these transects, I quantified the percent cover of hog damage and I surveyed the mussel densities. Here are my results. So on the Western Marsh, you see about 27% hog damage throughout the entire marsh, the north and south portions. But on the Eastern Marsh, we see a very small amount of damage. It comes out to about 0.5%. So we can see that there are pretty significant differences in hog damage on these two marshes. And so we evaluated one of the possible causes of this by looking at a land cover map from the St. Johns River Water Management District. And you can see that in the upland area surrounding the Eastern and Western marshes, we see pretty different land cover. So in the Western Marsh, we see a lot of forested uplands, whereas in the Eastern Marsh, we see shrub and brushland and residential areas. There's a lot less of that brownish forested upland. And that forested upland is the habitat where the hogs are living the majority of their time. And so this difference in land cover likely explains the difference in trampling and other sources of salt marsh damage that we observed in our surveys. And this has been reported in other similar surveys of hog damage in salt marshes. Now that we know that the hogs are concentrated in one marsh and not the other, we can look at their impact. And so we first assess the impact to mussel populations. We see that there are pretty significant differences in the number of mussel mounds on the west and east salt marshes. There's significantly more mussel mounds on the east marsh, which does not have hog damage. Similarly, eastern marshes have larger mussel mounds than the western marsh, but the western marsh showed significantly more crushed mussel shells recorded in our transect. And so from this, we can conclude that hogs are predating mussels on the Western Marsh based on this crushed shells and decreased mussel numbers. But to confirm that hogs and not other factors were driving this difference in mussel patterning, we deployed a caging experiment. So we transplanted caged and uncaged mussel mounds on both salt marshes. And these cages were tomato cages, similar to what you would put in your garden. And they allowed access by crabs and raccoons and other smaller animals while excluding the hogs. And after 6 weeks of caging, we recorded predation in about a quarter of our uncaged mussel mounds, but all predation impacts were in uncaged mounds on the Western Marsh. We didn't record a single predated mussel within our cages or on the eastern side that doesn't show significant hog damage. And so from this, we concluded that hogs are definitely driving the mussel patterns we observe. So now that we've confirmed that hogs are actually driving differences in salt marsh composition, we wanted to evaluate how their trampling and mussel predation impact marsh functioning. We measured a whole host of response variables that we split into 2 different categories. So we have geomorphic and biogeochemical responses, so bulk density, organic content, ammonia and nitrate in the pore water, and then ecosystem function and service variables. And for the purposes of this talk, I'm going to focus on the ecosystem function and service variables. So we measured primary production and secondary production in Cordgrass. We measured denitrification using continuous flow core incubation and biodeposition by deploying filter papers directly adjacent to mussel mounds and catching their biodeposits that they produce during filter feeding. And in case you were wondering, here's a brief overview of the impacts of hogs and mussels on our geomorphic and biogeochemical responses, because they do drive some of the results we see in our ecosystem function and services. So hogs decrease soil bulk density, they increase organic content and ammonia, and mussels, but not hogs, decrease pore water nitrate. We measured those 4 ecosystem function and service variables that I just mentioned, first at the local scale. And so this was in 1 meter square of hog damaged marsh, undamaged marsh, or mussel mounds on both sides of the Guana River marshes. I'm going to show you a few different graphs that look just like this. So just to orient you, we have our hog damage, undamaged marsh, and mussel mound areas. We only have hog damage on the western side because there only were hogs and hog damage on the western side. And so that's why you see 5 variables going across this graph. But first, looking at primary productivity, we see a drastic decrease in primary productivity at the local scale within hog damaged areas. But interestingly, the highest bar on this graph is within undamaged marsh on the same western side. Secondary productivity we measured as crab biomass, and this was decreased within hog damaged areas and also in the western marsh generally compared to the eastern marsh. And our highest crab biomass was recorded in mussel mounds on the east side. Denitrification, so the amount of N2 flux that was removed from the system, was highest in mussel and hog damaged areas compared to the control marsh. There's no significant difference between the hog damage or the 2 mussel treatments. And finally, biodeposition, which is a mussel-driven process, and so only measured in the mussel mounds, was higher on the eastern side than the western side. And this makes sense because the mussel mounds were larger on the eastern side. So it's not surprising that they have a greater amount of biodeposits. But then we scaled all of those local scale measurements that I just showed you to the landscape scale. And we did this based on the percentage cover of hog damaged areas and mussel areas recorded during our transect surveys. So for each response variable, we scaled it up using the 27% hog damage and 1% mussel cover that we recorded on the eastern side, and the 0.5% of hog damage and 4% mussel cover we recorded on the non-hog damaged marsh. And so now we only have 2 bars because we're scaling up to the landscape scale, accounting for those percent covers that we recorded. And we see that primary productivity was increased on the Western Marsh compared to the Eastern Marsh. Secondary productivity was decreased on the Western Marsh compared to the Eastern Marsh. Denitrification was greater on the Western Marsh. And biodeposition was the most striking result, and this was significantly smaller on the Western Marsh than the Eastern Marsh. But the results are most interesting when you look at the local and landscape scale results together. And so I'll walk you through this because there's a lot happening in this figure. But if we start with primary productivity, we can see that at the local scale, it's decreased in the hog damaged regions, but at the landscape scale, it's elevated on the western side. And this is because the mussel and undamaged marsh areas on the western side showed a higher primary productivity than those same areas on the eastern side. And one possible cause of this is the higher pore water ammonia we recorded on the western marsh. Denitrification is arguably our most interesting result, and that's because we recorded a greater denitrification on the Western Marsh than the Eastern Marsh. This result is because at the local scale, hog damaged areas have a similar rate of denitrification to the mussel areas, and they account for a larger area. So that 27% of the marsh being damaged by hogs, when you scale that up, we see that denitrification is greater on the Western Marsh than the Eastern Marsh. And finally, this biodeposition result, the local scale results are compounded at the landscape scale because of the drastic differences in mussel cover. So overall, we see that hogs are causing significant damage in the Western Marsh of the Guana River through their trampling and mussel predation. The upland land cover is driving hog access. Hogs are reducing mussel cover by about 68% across the marsh landscape. And then at the landscape scale, hogs are increasing primary productivity and denitrification, but decreasing secondary productivity and biodeposition. And that is all I have. So I will take any questions. Thank you so much.
Awesome. Thank you so much, Hallie. It was a great presentation and a really interesting addition to the salt marsh story in our marshes. Why do you think the hogs are increasing soil organic matter through their trampling?
I think it's likely that they are destroying the cordgrass during their trampling, and that cordgrass is breaking down and increasing soil organic matter.
Awesome, thank you. Are there any additional questions for Hallie? We have plenty of time for questions. What next steps do you see moving forward with this project, Hallie?
I think it would be really cool to look at this in different salt marshes. So the study is limited to just the Guana River salt marshes, but we know that hogs are in other marshes in the region. So I think it could be easily translated to a different marsh.
Definitely. Why do you think there was no evidence of hogs in one of the marshes here at the Guana River marshes?
Because the upland habitat is so different. So hogs rely on forested upland habitat. That's really where they live and use as a refuge. And then they just travel into the marsh to forage or wallow. So because there's such limited upland forested habitat on the eastern marsh, it's Like the hogs are staying on the western side in the WMA area.
Interesting. Thank you. Do you think bioturbation from the hogs could increase the decomposition rates and potentially affect elevation loss in the marshes?
Yeah, I absolutely think that they could. So we know that their oxygenation is important in the nitrogen fluxes. That's our leading hypothesis for why we see increased denitrification in the hog areas, is that they're aerating the soil. So I think it will likely translate to decomposition as well, although we didn't measure that. And other studies have shown that damage by large grazers does decrease salt marsh elevation. And then also the biodeposition that we recorded is important for elevation because the mussels are pulling sediment out of the water and depositing it onto the marsh. So on top of elevation losses that are driven by decomposition, we're also seeing reduced biodeposition because of the reduced mussels. So together, I think those are really important for hogs impacting these marshes with sea level rise.
Thank you. Do you have a sense for how guana hog population densities may compare to other areas?
I don't. Other people here might have a better idea of that than I do. I know that there has been some efforts made recently to start to quantify the hog population in the Guana region, but it's a relatively unknown area right now.
Definitely. Do the hog trails turn into runnels in the marsh?
Yeah, they absolutely do, especially the ones that run parallel to the upland border. Those are pretty permanent, at least over the 18 months that I have been surveying these sites. It seems that the ones that run through the marsh towards the marsh edge revegetate if they're not continuously used, but the ones that run parallel to the marsh are pretty constantly underwater, even at low tide.
I don't know if you could speak to this real quick, Hallie. Do you know of any control or mitigation happening for hogs in this area? I know we at the reserve are working on that, but do you have any comments to add to that?
Just that it is a heated topic of discussion among managers in the region. So.
Definitely. Well, thank you, Hallie.